Hello and welcome to this short tutorial video where I show to you how to use the LVGL graphics library with the ESP32P4 system chip offered by ESP under its HDMI development kit. My name is Felipe. I'm a maintainer of the LVGL and I'm working specifically with the LVGL and video accelerator using the ESP hardware and specific chip details. So before we get started, let's do a quick recap of what is LVGL and how it's related to the ESP32P4. The LVGL is a graphics stack that allows us to create a beautiful user interface with a comprehensive set of widgets and basic shapes and all the subsystems that you need to integrate it to your next embedded display design. And the ESP32P4 is the flagship offered by ESP that has a comprehensive set of capabilities to drive embedded display and produce beautiful UI. So there's a mat here. So besides the dual core RISC-V CPU, the P4 offer a set of accelerators that could be used for accelerating the rendering of basic shapes or like its pixel processing accelerator and the DMA2E. The pixel processor accelerator is a controller that will accelerate the typical pixel operation that you need to do on 2D images like blending, copy and filling, and rotating and scaling and doing mirroring of the next object to be rendered on the screen. And the DMA2D is a unit that accelerates the copy of 2D objects like images and Shalom Every and peripheral. It's aimed to reduce the latency between the time that you send a draw buffer from a peripheral to memory or from memory and a peripheral. So in this video, I will be showing to you what are the minimal components that you need to use the LVGL on the ESP32 EV Function board, by showing what are the minimum things that should be added to a project. So before we get starting on the projects, let me do some clarifications. I just have here this ESP32P4 demo folder, and as you can see, it's a very simple folder, and I'm using the plain IDF installed on my machine. So I'm not using the ESP IDE or any other plugin to my VS Code, just the plain IDF installed on my machine and in a system-wide way where I can just import the IDF commands here. And in the left corner of my screen, I have my P4 EV Function board attached to my laptop. It's running one of the example. We'll dive it in detail in the next section of the video. And I will be interfacing with the IDF by just using the regular command line interface. Okay, so let's start with how the LVGL component will interact with the ESP32 or ESP32 project. As you can see here, there's no any mention of the LVGL because LVGL does not interact directly to the project. It get imported by IDF Component Manager, so which is a tool that's responsible to manage the dependence of software components depending on your application requirements. But before entering in detail of it, let's talk about the minimum file that you need for your IDF project. The first one is the top level CMake file, where it will be generated by your IDM or your plugin, but you can just copy this over from another IDF project because it's just a boilerplate of code. The only thing that you can change here is to do the project name for your demo. And once you have this file in place, you can optionally create the SDK config.defaults, because this file will override the default options of your IDF project. So here you can set the configurations that should be permanent in your developed application. This includes the interaction with the LVGL. So the options of LVGL can be placed here, and it will be retained every time you build or rebuild the project. So the next file that we need to create here is the main folder, which is the folder that instances the main component of the IDF project, which is the entry point of your application. And this folder has two manipulative files: your source folder or set of source folders, and the CMake build file, where you can just register the main component. And the thing that you need to pay attention here is your source. So let's suppose you have your main application here, and you would like to separate your LVGL UI file from the main application. So you can just create your UI.c file here, and it will be added to the build, and you can add it. So after you added these two files and your entry point with your add main, you are ready to go. So this thing we will add later. So what is the role of this IDF component YML? This file in general is not edited by hand. You generated it by using the add dependency command of the IDF. So this file will be generated as a manifest of the components required to build this application. In this case, we are seeing only one component, which is the P4 function EV boards. For this case, all the needed components, including the LVGL and its port independence, will be brought to this project after this component gets imported. So to generate it, you can just go to the command line and use the add IDF ID dependency and pass the namespace of the component and the component that you would like to add. In general, this can be also this form, so LVGL for blend LVGL or LVGL words component, and you can use it 2 or 3 commands. So you can use LVGL and LVGL port components. This file, the manifest file, will be created here, and will tell the application to pull this software components on your project after the target is set. So, but for making this thing more easy, we are just using the expressly supported board supported package here in handling in the here in the dependency. Once you execute this file, this command, this file will be generated and with all the components you need to build your project. So after we place that, we have everything in place. So for your demo application, we can do the simple app application possible, which is bringing the include files for the FreeRTOS, the LVGL, and the board support package, and use the board support package to turn on the display, and finally call the LVGL demo benchmark entry point. It's a very simple application, and now we are ready to go. But you might be wondering, where are the source files of LVGL and LVGL port components? So once you created this structure, you can just prepare your plate for building. In this case, using the P4. Just to recap, the target name of the IDF set target command should be in lowercase. So hitting enter, it will start to prepare the project. And for the first time, this command will take some time because it will start to pull out all the needed components in a recursive form. So if it pulls a component that depends on another component, this component will be pulled as well. So this is what happens. We have this P4 function EV board component that depends on LVGL port and the LVGL itself. So they are pulled as well. And here we have our regular LVGL graphical stack here, and we can interact with all the files. So after these files have been pulled, or this command is completed, we can proceed with the building. So to build the IDF application with the LVGL support, there's no special steps. You can just hit view, flash, and monitor. You can concatenate different IDF commands into a single line. So build will build the compile the project. Flash will flash the board, which is already connected to my computer, and the monitor will start the log console where you can see some useful material. So I hit OK. The first time it will be, it should take some precious minutes to build, but on the incremental rebuilding, it should be faster. So now it's connected to my board, and it should be deploying the binary with my dim benchmark on that board. And hurry up. So we have the log components here working, and also in this corner of the screen, and here you can see the demo proceeding, and here we have a lot of messages telling us what's happening on the console side. We can just turn them off when needed in order to get some extra frame rate, but in general, for the development purpose, it will be turned off. And you might be wondering also, where's the pixel process accelerator and the DMA2D? They are enabled by default. So here they are set by the build system in the moment where you import the component, and the user interaction with them is transparent as possible. So you don't need to do any extra step because the PPA will be enabled by default. So how we can do key interact with the LVGL. So let's pick one example. So here we have the LVGL website. So here I'm just picking one of its examples. So let's go back. Just the frame. Some bad contacts with the with cables, but everything's okay. So now we have the UI example right here, and it's simple using the LVGL API because we have the main include here. So let's do a rebuild, which is faster, since we don't need to build the entire SDK again. There you go. We have here the button, and as you can see, I can also interact with the HDMI because the in-dev is already connected to the touchscreen controller, so we can produce not only the output feedback but also the input feedback using the touchscreen. And also we can, the in-dev is also here every time I touch on the screen, which is very helpful during the debugging. Okay, so this will conclude our short tutorial about the LVGL usage with the P4 EV function boards. I hope you enjoyed this video, and if you would like to hear more information regarding the ESP32 and LVGL integration, please visit lvgl.io. So, thanks for watching.